Hello, this is Richard Gillespie. Welcome to Perspectives. This is a series of videos that I've put together to discuss some of today's relevant topics to bring the information into, say, perspective, overall perspective. Today we're going to talk about geologic events and how these have influenced the populations and the history of and the distribution of Homo sapiens on the planet. And this is something that is a little bit controversial at the moment, but anyways, we're going to get right into it. We're going to start 74,000 years ago with the eruption of Mount Toba in Indonesia. At that time, the planet was going through a glacial maximum. So we had two things happen. We had the largest volcanic eruption that we know about in the geologic record of any time happening at the same time that we had populations worldwide that were being severely stressed by glaciation, by a glacial maximum. And as the theory goes, we have to look at the population in Asia. Toba covered Asia with a layer of ash 6 inches thick, and the theory is that most of the population died throughout that event. And the reason that people think that is because the genetic variation of people from India is the lowest variation of any population on the planet. This means that they originated from a very few number of individuals. So the theory is that very few individuals survived Toba, and those people went on to be the forefathers and mothers of the current population of India. At the same time, the Homo sapiens who had evolved in Africa were being pushed further and further south. And in fact, they ended up a small population at the bottom of South Africa, living in caves and living off marine wildlife, marine life. And this population, it's theorized, gave rise to the population that went on to populate Europe and Asia and the rest of the world. But the population that originated from this small group may have been as low as 600 couples. And this was due to the severe conditions that were created by the Toba eruption in conjunction with a glacial maximum. We know that the number of individuals was as low as it is by measuring the variation of DNA within the populations outside of Africa. So it means one of two things: either the population that left Africa to populate the rest of the world was only one small group, or it meant that population of Homo sapiens was pushed right to the limit because of these geologic events. In either case, the population of Homo sapiens outside of Africa is extremely low. And when we look at the population of indigenous peoples of North America, that's also very interesting. Recent DNA studies have shown that these people originated from a group of individuals that were from Beringia, which was the exposed land between Alaska and Russia that was exposed during the last glacial maximum when the sea levels were 120 meters lower. But the interesting thing is that all of the people of North America seem to be genetically related to as few as 70 individuals that left Beringia. So there was not a series of migrations from Beringia. It was one small group that left, and that one small group gave rise to the entire population of indigenous peoples in North America. So that's quite remarkable. So the North American Indians, or North American indigenous peoples, pardon me, have a very low genetic variation, and that's because they originated from such a small population. And this was roughly 13,000 years ago. So that basically gives you a little bit of a summary and perspective on the variation of how populations spread out through the world, and so why do we have so many people now? And the reason is just because we've had a very stable climate for quite a period of time now, and the advent of agriculture. So we have a lot of people, but also I think that what happened in these times of extreme stress on our populations, that the ones that had the strongest ability to reproduce were the ones that went on. And so we have populations arose that had a very strong tendency to propagate, to populate, and therefore the populations really exploded. But genetic variation amongst Homo sapiens, for example, if you took two chimpanzees from the same troop in a troop in Congo, in Africa, those two individuals would have more genetic variation between them than any two people on the entire planet. So that gives you some idea of just how similar we all are. This also gives you some insight into why we have pandemics, and why we have, when a disease hits, it'll run right through an entire population. And that's because we all have the same genetic makeup. We haven't been around long enough for our genetic variation to increase, so that everybody has the same tendency to be exposed, or to react to these pathogens. So when you do get a virus or something of that nature, it'll run right through the entire population very quickly, because we all have the same genetic makeup and the same resistance. So we don't have some individuals. We have some individuals with higher resistance, but on average, generally speaking, our populations, because of our low genetic variation, are very vulnerable to diseases. Anyway, that gives you some perspective of where, how populations throughout the world have evolved, and this has all happened in the last 30,000 years, which is really just a very short period of time. Homo sapiens have been on the planet for roughly 200,000 years, and they've been living outside of Africa for approximately 30,000 years. The first indigenous peoples came into North America approximately 13,000 years ago. The oldest indigenous person in North America to be discovered was a girl in a cave in the Yucatan Peninsula, and DNA showed her to be 13,000 roughly years old. And that's a pretty recent time when you think about it. 13,000 years is not a long time ago. So that is that's my perspective on human populations, where they came from, why we are susceptible to disease, and it's just very interesting to know that we all originated from a very, very small population not very long ago. Thank you.